Everyone, in this video we're gonna learn how to solve this geometry math Olympiad problem for 5th graders in China. Before we're gonna start, let's pause the video and give you a try. Alright, let's get started. So, given the picture, the question asks us to calculate the area of the shaded region right here. Alright, and note that these geometry problems only for 5th graders. So I don't know if 5th graders learn the law of sine or law of cosine, but in the United States, normally students learn law of sine or law of cosine in algebra 2 or precalculus. Recall the law of cosine. So if you given this side length, you given this side length, and you given this angle right here, right? We call this angle C, and then you have the side length C right here. Now, in order to find this side length, C square equal A square plus B square minus 2AB multiplied by cosine of angle C. Alright, so keep that in mind. We're going to use this. So let's get the picture as follows. We observe that B right here is the center of the circle. This circle right here. Alright, and D right here is the center of this circle. Alright, so keep that in mind. Now observe that BE right here, right? Because B is the center of the circle right here, so BE must be equal BA, and they're both radii. So this guy 10, this guy must be 10. Alright, now O right here is the center of this circle. M is the tangent point. So BC becomes a tangent line. Now, BC equal 10 and then BM must be equal 5. OM is the radius of this circle right here. So OM must be half of DC. OM equal 5. Alright, you use Pythagorean theorem, you can calculate BO equal 5 root 2 for this triangle. Alright, now we know that OE is the radius of this circle O. So OE must be equal 5. Alright, so we apply the law of cosine. We need to calculate the angle right here. EBO. Okay, so I know the angle B right here. Opposite to this side length right here. So have 5 square equal 10 square plus 5 root 2 square minus 2 times 10 times 5 root 2 cosine of angle EBO. Alright, so we just simplify this one. 5 square equals 25. This is 100. 5 root 2 square is going to be equal 50. Minus 2 times 10 times 5 is going to be 100 root 2 cosine EBO. Alright, now we simplify 100 plus 50 is going to be 150. And then we move this one to the left, move this one to the right. So I have 100 root 2 cosine EBO equal 150 subtract 25 is going to be 125. Alright, so cosine EBO equal 125 divided by 100 root 2. Alright, so then we need to find the measure of angle EBO. So the measure of angle EBO should be equal, right, cosine inverse of 125 over 100 root 2. Now, since this triangle right here, EBF is the isosceles triangle, and OB right here is the angle bisector. So then this guy right here must be equal to this guy. So in order to calculate EBF, you need to take EBO multiplied by 2. So I have the measure of angle EBF equal 2 times cosine inverse of 125 divided by 100 root 2. Now, similarly, we need to find the measure of this angle right here. Alright, so basically, we apply the law of cosine into the triangle E, O, and B. Alright, so we have 10 squared, because this angle opposite to this side length, so it could be 10 squared equal 5 squared plus 5 root 2 square minus 2 times 5 times 5 root 2, and then cosine of angle EOB. Alright, now we're going to simplify this one. So 10 squared is going to be 100 equal 25 plus 50 minus 2 times 5 is going to be 50 root 2 cosine EOB. Alright, so move this one to the left, move this one to the right. So it turns out to be 50 root 2 cosine EOB equal negative 25. Alright, divide both sides by 50 root 2. So cosine EOB equal negative root 2 over 2. And then you need to find the measure of angle EOB. So EOB equal cosine inverse of negative root 2 over 2. Alright, so we have moved it to the left, so it could be 50 root 2 cosine EOB equal 25 plus 50 is 75, subtract 100, it could be negative 25. Divide both sides by 50 root 2, so cosine EOB equal negative 1 over 2 root 2. And then you need to find the measure of angle EOB. It's going to be cosine inverse of negative 1 over 2 root 2. Now observe that this guy right here, this angle right here, and this angle right here must be the same. Alright, so you have this one, it's going to be cosine inverse of negative 1 over 2 root 2. And this guy should be the same. So basically this guy is going to be double this guy. Alright, so you multiply this guy by 2. Right, so so next one you need to find the measure of this guy right here. So it's going to be 360 degrees, subtract this guy and this guy. So I have the measure of angle EOF equal 360 degrees, subtract 2 times cosine inverse of negative 1 over 2 root 2. All right. All right, so it's roughly 138. So it's gonna be 138 degree. All right, so this the measure of this angle is gonna be 138. Now think about the circle B right here, and now think about the circle B right here. We need to find the area of the sector B, E, F. Alright, so the area of the sector B, E, F. So we use the formula part over whole equal part over whole right here. Alright, we substitute the area of the sector EBF. So I have area of the sector EBF over the area of the whole circle, right? The circle B right here. So the area of the circle B equal EBF, we got it right here, 56. So it can be equal 56 divided by the whole thing right here, which means 360. Alright. So the area of the circle B right here is going to be pi r square. Alright, r is going to be 10 right here. Alright, so I substitute this is going to be equal 10 square times pi. Alright, so the area of the sector E, B, F equal 10 square times pi times 56 divided by 360. Square could be 100 times 56, it could be 5600 times pi. And then divide by 360. It's going to be roughly 49. So it's going to be 49. So we just calculate the area of this sector right here. Alright. Now we need to calculate the area of the triangle EBF, which is this one. And then we subtract it from the area of the sector to get this one right here. We need to find this one right here. The area of the segment right here. We need to find this one. Alright. So we need to calculate the area of the triangle EBF. So the area of the triangle EBF. Alright. It's going to be 1/2. Alright. 10 times. This is 10. So 1/2. The product of two sides. So 10 times 10. And then multiply the measure, the sine of this angle right here. Multiply by sine of the measure of angle EBF, but EBF equal 56 right here. So sine 56. Alright. So it turns out to be 10 times 10, 100 divided by 2. It could be 50. So it could be 50 times sine 56. Alright, so it's roughly 41. Alright, so basically you take this one, 49, subtract 41, you get the area of segment. So the area of segment, the right segment right here, which is E. This is N, this is N. E, N, F right here. Alright, this one right here, the area of segment right here. So E, N, F equal 49, subtract 41 equal 8. Alright, next we need to calculate the area of the sector EOF in the circle O right here. Okay, so we need to calculate the area of this guy right here. And then we subtract the area of the triangle right here. And then we subtract the area of the segment right here. And then we will get this guy. And we multiply this guy by 2, we get this guy. Alright? So, now the area of the segment. So, now the area of the sector EOF. Right? We use the formula right here, part over whole. Alright? So, I have the area of the sector EOF over the area of the circle O, okay? Area of the circle O equal. Now the measure of the angle O right here, we just calculate it, 38. So it could be 138 divided by 360. Area of the circle O is going to be pi r squared. Now pi r squared, radius should be pi. So it turns out to be, now I erase this one. So it turns out to be pi r squared, right? So it's going to be 25 pi. Alright, so the area of the sector EOF equal 25 pi times 138 divided by 360. Alright, so we bring up the calculator. So we have 25 times pi times 138 divided by 360. So it's going to be 30. Alright. Now, we need to calculate the area of the triangle EOF. So the area of the triangle EOF is going to be equal 5 times 5 and times sine of this angle. So it can be 5 times 5 1/2 times sine of angle O. But angle O, we got it right here. Angle O. EOF. It's going to be 138. So sine 138 is going to be 5 times 5 is going to be 25. 25 divided by 2 is going to be 12.5 times sine 138. It's going to be 8.4. 8.4. Alright. Now, the area of the shaded region. Area of the shaded region. It's going to be equal. Right? Equal. The area of the sector EOF. Sector EOF 30. Subtract the area of the triangle right here, 8.4. And then subtract what else? The area of the segment right here, which is, it's going to be 8. 8. So, 30 subtract 8 times 8. So, 8 plus 8. So, 8.4 plus 8 can be 16.4. Subtract from 30. So it can be 13.6. Alright, so then this is just the shaded region right here. And then you need to multiply by 2 to get the top right here. So then you need to multiply by 2. So the final answer must be 27.2. And this is the final answer. And it's a good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.